Hey, good morning. We're into functions still. Today we're going to take a little bit of a twist on functions that we're going to get some functions that are what we call scatter plots. And we're kind of coming to the end of our section on functions. We started out by looking at what a function is, vertical line test, looking at our domains, ranges. Then we also went to recording domains and ranges. Yesterday we went to writing equations or writing the functions from words and graphing them. Today we're going to take some of these functions and we're going to look, and they're still going to be functions, but they're not going to be in a nice straight line like most of our functions are. So we call that a scatter plot. On our warm up today, I'll do it kind of with you because I know you guys most of you didn't go to math fourth quarter. Some of you guys still did the work. During fourth quarter, your teachers gave you assignments and you continued with your learning. Some of you, for whatever reason, didn't continue your math lessons on fourth quarter of eighth grade. And this is usually where you start this y equals mx plus b stuff. And so I'll help you through this in case. It'd be really nice if you knew what this stuff was. But if I have an equation and I get it into the y equals mx plus b form, it's really easy for me to graph. And so after our test on next Tuesday, we'll talk extensively about this because we don't want to make a t-chart every time we do a graphing of an equation. And so if I had something like this, y equals 3x plus 7, that's in the y equals mx plus b form. M stands for my slope. And so when I go to graph it, that's going to be my slope. So in this case, I would go up 3 over 1. This part down here, my constant, is what we call the b, and that is my y-intercept. So the y-intercept means where does it cross my y-axis. And so what I would do is I would go, if I was graphing this equation, and we'll do lots of this, I'd go to 7 on my y-intercept right there. Let's just pretend that's 7. And then I have a slope. It's a positive slope, so that means my line should be going in an upwards direction. And my slope is up 3 over 1. So from that dot, I'd go up 3 over 1, up 3 over 1, and then I would draw my nice straight line. So that's it in a nutshell. So we call this slope-intercept form. All right. So the next one says, this equation of a line is y equals minus 2x plus 6. What's the slope of the line? Well, the way we notate that is we look for the number, the coefficient of the x if it's in the form. And in this case, it's a negative 2. So what we do is we say m. M stands for slope equals a negative 2. Okay, so whenever I see an m in algebra, we usually refer that as the slope. So we try to stay away from that and using it as a variable for I don't know, what could be for an m, math books, number of math books. If we were writing an equation for the number of math books, we'd probably stay away from the letter m. We'd use b maybe for books as our variable. All right, so we have to manipulate some of these get it into the slope-intercept form. And so that means I want my y over here all by itself on the left-hand side, and I want everything else on the right-hand side. And so in order to do that, I'd subtract an x from both sides. So now I have a minus 2y. We want to put our x's first, and then we want to put our constant. But I still don't have the y by itself. I want to have to divide by a negative 2. So I'm going to go and write my final answer over here. My 2's cancel out, so my final answer is y equals, there's really a 1 in front of that x. So a negative divided by a negative is a positive, so I'm just going to leave it as a 1/2 x. And 4 divided by negative 2 is a minus 2. So that's going to be our goal with equations when they give them to us, is to put it into the y equals mx plus b form. All right, so now that we know the parts of y equals mx plus b, they said, well, here's the slope, and here's my y-intercept. So we want to say f of x or y. If they said a function, we just put f of x there. it's always going to be something x. And so it's y equals mx plus b. So where the m is, that's where I want to put my slope. So that's going to be my coefficient of the x. And my b was a -4, they said. So there is my equation. All right. All right. I'm hoping that you got to that last year in 8th grade. But again, it's usually around the 4th quarter that they start that and really hit it hard. All right. So today we have these things called positive and negative correlations. I'm sure you got to some of that last year. Positive correlation just means on my graph, as I'm graphing and looking at my graph, they're tending to go from left to right. We're going in and upwards. And a negative correlation means we're going from left to right. We're heading in a downward fashion. We're going to draw a trend line today. So you need a ruler. And you're going to need a ruler for many, many days after this next test. So if you don't have one, get one. Scatter plot is just that. It's a bunch of scattered dots that we kind of look for a pattern here. And when we see a pattern, we call that a correlation. So we got lots of new vocabulary here today. All right, so here we go. Ecologists can use scatter plots to help them analyze data about endangered species such as ocelots, I think is how you say that. In this chapter, you have examined relationships between sets of ordered pairs or data. Displaying the data visually can help you see relationships. A scatter plot is a graph with points plotted to show possible relationships between two sets of data. A scatter plot is an effective way to display some types of data. And so here we are doing our first scatter plot. And so what I'd like to do is point out some things on graphs. All graphs for the rest of your life should have lots of things. On the next graph, you're going to have to make your own. When we have our data here, we want to look at our highest number and our lowest number. And so when we use our scale here and we're making our graph, we want to use up most of the graph. So, here it looks like they're counting by ones every year, but they skip every other one to name it. We also want to look at our highest number in our data, which in this case is 91. And so we want our graph to come up as high as we possibly can to use up our space. And very, very, very important, all graphs for the rest of your life need some labels. This one's years by species. So when we go to making our own graphs and our word problems, you have to have labels. Title would be nice up here, so that if somebody is looking at your graph will know that, here's the number of species added to the list. So let's go ahead and graph that. They did a whole lot of work for us. In 1996, we had 91. I get it, they're counting by tens, but we just kind of come as close as we possibly can to look for a pattern. 79, 1998, 62. Boy, there was a big drop. Went from 62 to 11. And then we went back up a little bit. So as we look at this graph in general, we can obviously see now that as the years are progressing here, the number of endangered species added to the list is decreasing. All right. Notice also that on this chart here, these are my x's. So that's my x-axis, and this is my y's. And so if you're having trouble labeling, look over there at those labels and when they give it into our data chart. For example, here you need to have games on this scale down here, because that's my x's. And then I need to turn my paper sideways here. Scores is my label over here. So my highest number on my x-axis has to be a 4. So we don't want to say 1, 2, 3, 4 and have all this empty space over here. So we kind of need to figure it out. And sometimes we have to erase things, but this will be a pretty easy one. If I skip every one, I think I will be okay. Yep. So I used up my whole axis there, my x-axis, and I want to still be able to do my highest score. Now, when you make your vertical axis scale, we want to look at our highest number. Our highest number is 46. So we don't want to count by tens, because 10, 20, 30, 40, 50, we'd only be using up half of our graph. And so see if you can come up with what kind of a number you would think is best. If you're thinking twos, that won't work, because 2, 4, 6, 8, 10, 12, 14, 16, 18, we got to have it to 46. What if you tried 5? Let's see if that works. 5, 10, 15, 20, 25, 30, 35, 40, and 45. My highest number is 46, so I can still get that on there. So counting by fives would be a good scale to use. All right, go ahead and plot those points. I have it on the next screen. Okay, welcome back. I hope your points kind of look like that. They're not linear, but it is still a function though. So if I did my vertical line test, there would be only one dot under each of the dots on my vertical line test. So it's still a function. Okay. Now I'm hoping that you've seen some of these. So as I'm looking at my group of dots here, they kind of form a group here. And as I work from left to right on my x-axis, they're increasing. So we call that a positive correlation. Some people call it a positive trend. Okay. As I look at my dots here, as I again go on my x-axis from left to right, I see that they're all kind of decreasing. So we call that a negative correlation. Yes, you have to write the word correlation. And then here, the dots are like all over the place. Some of our graphs look like this sometimes. And so that would be a no correlation. All right. So here, watching TV and test scores. So the way I usually encourage you to kind of not just look at the dots, but look at the labels too and think about, because pretty soon you're going to have to interpret these graphs. Friday, I think we do interpreting the graphs. So let's start interpreting it now. Here, if I watch 0 hours of TV, my test scores are pretty high. And then kind of as I watch more TV, 1, 2, let's just make up some numbers, 3, 4 hours of TV, my test scores go down. So I'm probably not studying for the test. I'm probably just watching TV and vegging out. So this is a negative correlation. And let's go back up to the directions. Do they ask me to explain why? Nope, they just say, is it a positive, negative, or no correlation? All right, so that would be a negative correlation. But again, look at the scales of what's happening here. Snowboard competition is what this graph is called. And so as my years increase, my number of participants seems to be increasing. There kind of seems to be a group of numbers here, and they seem to be going in an upward fashion. So write what correlation this one would be. And I hope you wrote a positive correlation. Please write the word correlation. Okay. Correlation means a group of dots. Okay. All right. Now we have to kind of do some thinking. There's a whole lot of writing here because we have to explain. It says identify the correlation you would expect to see between each pair of data sets. Explain. So the number of empty seats in the classroom and the number of students seated in the classroom. So you got to kind of visualize this and think about it. And think about, if I have a number of empty seats. So if I have lots of empty seats, that means there's not very many kids in the classroom. So for example, my classroom right now has nobody in it. I have lots of empty seats. So that means very low or no students in my classroom right now. But as I go through the day, the fewer the empty seats I have, that must mean there's more kids in my classroom. So as I think about this, it's going to be a negative correlation. What would that look like? Well, kind of if I graphed it here and I had a number of students in my classroom. So if I had lots of students in my classroom, or let's do it the way they put it. Let's do empty seats. If I had empty seats, if I had 0 empty seats in my classroom, wouldn't that mean there's lots of kids in here? My class is full. I'm going to try writing sideways here. Lots of students. So I'm trying to visualize this. And so sometimes I'll do this up. If I had 5 empty seats, well, then that means there's fewer than what I started with in here. And then if I had 10 empty seats, that would mean I have fewer kids. And then if I had 20 empty seats, I would have something like this. And so I see this negative trend here. Now what you have to do is you have to write it in words. Explain, it says. Explain, which is a lot of writing. So we want to say as the number of empty seats increases. So here's my empty seats. As these guys increase, so put a comma, the number of students in my class decreases. And that would give me a negative correlation. Okay, so sometimes you might make a little graph over here. The number of pets a person owns and the number of books that person read last year. So think about that. If I had 0 pets, does that mean I read a lot of books or no books? If I had 15 pets, animals like rabbits, dogs, does that mean I'm going to read a lot of books? Probably not. Probably there is no correlation here on this one. Maybe I just don't like to read books, or maybe I do like to read books, but I don't have to necessarily go to see how many animals I have based on the books. Now, some kids in the past would argue saying, well, maybe they're studying up. Like maybe if I own horses, I want to read a whole lot of horse books, which is totally possible. And as long as you explain that down here, that you're going to read horse books, that'd probably be okay. But I would think in most people's cases would say there's no correlation here. And I would say then to explain it, the number of pets a person owns has nothing to do with how many books they read. Okay, we're talking about a general population here. Could we find some people that have a ton of pets and don't read any books? Yeah, or even so kind of we go with the general population. This one here I changed from Alaska because we didn't know in Alaska we don't have a reservoirs up there. And so I made it specifically for Arizona because you guys know what a reservoir is. If you don't, that's kind of like where the lakes where they build a dam to hold the water back so that we can use it throughout the year. So like in the springtime when all the snow is melting, it comes down the mountains and we make a lake out of that and fill the lake up, and then we kind of release it through the summertime. So the monthly rainfall. So again, I want to make kind of a temporary graph here. So here, rainfall. Sometimes this helps kids. If I have 0 rainfall, how much water is going to be in my reservoir? Right, nothing. But if it rained like 6 inches, well, I should have some more water in my reservoir. If it rained 12 inches, I should even have more. And so as my rainfall increases, my amount of water in the reservoir increases. So we would say this is a positive correlation. Okay, how come? As the amount of rainfall increases, So as I'm going on my graph from left to right, boom, it's increasing. There's 0, there's 12, there's more. So as it increases, comma, the amount of water or the depth of the reservoir increases. Okay, so we call that a positive correlation, and that's how we explain it. We have two events happening, what the axes are. So again, that's why axis labels are so important. All right. Well, I have my answers there for you. All right. Do the next try it. So see what you have. It's going to take you a little while. So pause your video and then I'll show you my answers. Okay, welcome back. Here's what I got. I said the temperature in Houston and the number of cars sold in Boston had no correlation. The temperature in Houston has nothing to do with the cars sold in Boston. Could be 100 degrees in Houston, but people in Boston, they don't care about the temperature. They just buy cars if they need it. So I said no correlation on that one. And there's how you would explain it. The next one says the number of family members and the size of the family's grocery bill. So I said a positive correlation because as the members of your family increases, comma, they eat more food, so your grocery bill should also increase. The number of times you sharpen your pencil. So kind of I had to make a little graph for this one. So first event is sharpening your pencil. So if I sharpen my pencil 0 times, well then my pencil's like brand new. If I sharpened it 5 times, well it should be shorter. If I sharpened it 10 times, it should be shorter. So again, sometimes a little graph on the side, a quick one, can kind of help you figure out what kind of a correlation it might be, help you organize your thoughts. So this would be a negative correlation, and the way you explain it is, as the number of times you sharpen your pencil, so that would be my label here, sharpening my pencil, increases, the length of your pencil decreases. Okay. So again, 2 events needs to be in your answer when you explain these. Okay. All right. Here's a scatter plot. Now it's kind of like interpreting too. It says choose a scatter plot that best represents the relationship between the number of days since a sunflower seed was planted and the height of the plant. Explain. Now, when we do these graphs and explaining, we also need to explain why one graph doesn't work. Okay. So in graph A, we have a plant, and again, labels are important. So on day 0, this plant is like, what are we counting by? 10s here? 40, 50, 60. This one's 70 inches tall already. And then something must have ate it a little bit, and then it stayed there, and then it grew up. So it's kind of hovering right there around 60, 70. And so if I'm talking about a plant that was planted from a seed, it can't be that one. It can't be that one because how about we spell because right? This plant starts at 70 inch or 60, 70 inches. So it can't be that one. What's wrong with graph B? Right, I'm hoping you're saying, well, here's time. You can't have a negative time. All right, now looking at this last graph, well, the time is 0 and the plant height is also 0 inches. It's still 0 inches, like 10 days later. Well, that's because it's under the ground. We can't even see it yet. And then it pops out and it's kind of growing along here in a positive trend. So yeah, this one's good. Starts at 0 and increases over time. Okay. All right. Here's you try it. Choose a scatter plot that best represents the relationship between the number of minutes since the pie has been taken out of the oven and the temperature of the oven. Explain. So again, don't forget on the ones that don't fit, you need to explain why it doesn't work. I got my answers on the next page, so pause the video and we'll see if your answers are similar to mine. Okay, welcome back. I hope I have the answers on the next page. There you go. So I like to go with the ones that are not first. First, letter B, I said, no, you can't because you have a negative time here again. So that's a kind of pretty definite. Anything that deals with time on the horizontal axis, that's kind of our go-to answer there. On this one, on C, this one says the temperature of the oven is 80 degrees, and after you take a pie out of the oven, you usually turn the oven off, and so this one shows the oven still warming up. It's getting hotter as time is going along here. So as time's increasing, our oven's getting hotter. So I came back over to A and said, okay, I like this one because if it was like 300 degrees, let's just say, I don't know what they're counting by there. Looks like 40s. So let's say it's 280 degrees, and after you take the pie out of the oven, you turn it off, and so then it starts gradually cooling down until it's about room temperature, and then we'll kind of see a flat line here because it's at 70 degrees, which your house is probably typically at 78 degrees. Okay. So I said yes, after taking the pie out of the oven, you turn it off and it decreases. I should have used temperature instead of the word it. Okay. Trend lines. Now, for some reason, kids in past years have really had a problem with this because they always want to draw the line through a 0. So trend lines do not have to go through 0, 0 on your graph. But what we do is after we kind of have all of our dots plotted, don't draw this oval here, but we kind of look at the oval here, and this is a positive trend. And when we draw our line, what we want to do is we want to draw a line that kind of goes right down the middle of our data. And so sometimes these are kind of difficult, but again, it doesn't have to go through. Let's see if I can find my drawing tool for lines here. I think it's under shapes. So what I want to do, and this is why you need a ruler, is I want to draw my line so it goes right through the middle of the data the best I can. There's a pretty good one. It does kind of go through 0 on this one, but if I look at my dots, I got like one below, one above. It hits a couple of them. So be careful when you draw your trend lines. Again, it doesn't always have to go through 0. I don't know how to use my tool yet, but let's see if I can draw my arrow. If I can select my line there. No, I should extend this line all the way to the axis there. Okay, so now I drew my trend line, and now it says based on the trend line above, which we're going to start writing equations because we can't write an equation if the dots are all over the place. So what we do is we draw a trend line, and then we write an equation for that line to help us do answers that are further out on the axis here. And so we want to kind of go to, based on our trend line, predict how many wrapping paper rolls you need to sell to raise $500. So our money's over here, so 500 is right here. So if we go over and again go to your trend line, don't go to the dots. We want to go to the trend line that I have, which is right there, and then we come down and figure out our x-axis. Let's see, they're counting by 25s. So I would say about 75 rolls. Okay. It is an estimate because our dots are kind of all over the place. All right. So with that, I think we're done for the day. So you have a practice 23. Let's see if you have to do any skills anywhere. Make sure you answer your questions fully. Okay, you're in high school now, so just don't put the bare minimum. Be very clear on your answers. It looks like all the scales and the labels are for you, written already for you, so that's kind of nice. But as we go along, they're just going to give us graphing paper and tell us to graph these guys. All right, well, have a good day.